So, hello everyone. Today's subject will be golfing in Ruby. You are maybe familiar with this kind of exercise because there are some problem of golfing on the Coding platform. For those of you who don't know what golfing is, it's solving a logic problem with code, but this time you have to do it while writing as few characters as possible. It may be kind of weird to do this presentation. How can you finally be a specialist in golfing? This is a very precise category. And there is a clear reason. Sebastian and I started 1 year ago to do stream on the coding game platform, especially Clash of Code, and especially shortest and reverse Clash of Code. So it's been 1 year, and we stream every Monday and Thursday. We learned a lot during these years, and we gather all of the information in a notebook. And for today's presentation, we will give you some of the tricks that we learned. There is still one important fact before we start. The fact that we did it in stream was kinda important, because if you do a Clash of Code on the coding game platform, your lobby will especially look like this. So maybe one bot and maybe some bunch of new players. If you do it in stream, your lobby will look more like this. And obviously, you have to learn a lot from these people, and that's why we are doing our talk today. So go follow us on Twitch, and I will put the link in the chat after.
So to show you the tips we gathered during this year, we will work on a coding game-like problem. So to introduce this problem, we will talk about a little story. So this is the story of Theo. Theo is working in a super secret services agency. He works with agents across the globe. And to communicate with them, he used a coding system. The coding system works like this. He sends them a package with different pages from different books, and he changes their first name with another word, which we will call the super secret word. And this is the key to decipher the coded message. And since his team is not the best agents of the service, he wants also to send them the code in Ruby to decipher the messages, and he will write on a subway ticket, so you have to make it as short as possible. So if we translate the problem in a more coding game way, this will be the input we receive for our script. The first line is the super secret word. The second line is the number of pages, and each line after is a page. So you have a different word, and at the end, the number of the page. To decipher the message, we have 3 steps. The first one is to select all the pages where the word appears. The word can be a substring of another word. So for example, we have golf as a super secret word, and if the page has golfing, we have to keep the page. The second step is to sort the pages by lexicographical order. So the pages where the number starts with 1, then the pages where the number starts with 2, and etc. And the last step is to transform each pages in a decoded word. And on this page, every word will give us 1 character of the decoded word. To do so, we have to transform 1 word and compare it to the secret word. We have to compare the number of consonants of our word with the size of the secret word. If our word has more consonants, we will take the first vowel of our word. If our word has less consonants, we take the first consonant. And if the number of consonants in our word is equal to the secret word size, we keep the last letter of our word.
So don't bother doing it. This is the solution. This is the solution of the problem, like we may do it in a production code. We can split this code in 3 parts. The input, when we get the standard input from coding game, the code when we apply all the logic that Sebastian told us, and the output where we give the solution to coding game. So in this part of the code, in the input port, we get the data from the standard input in 3 places. The first one in the super secret word variables when we do a get point chomp. The second one when we get the number of pages in n. And lastly, when we loop on n to get each page one by one separately. And we stock it in pages. The first and easiest tricks is the one who allows us to get the keyword. As the input is on several lines, we will receive the word followed by a \n. So imagine if the super secret word is Ruby, it will be always followed by a \n. The chomp method allows us to remove the last character of the line if it's a \n, \r, or that kind of thing. Here we can replace point chomp by point chop. Chop removes the last character of a string no matter what. And we know for sure that the last character will always be a \n. So we can replace by point chop and we gain by that one character.
So thanks to Julien, we only gain one character, but we have a lot of work to do now. The next line is the number of pages. And for now, we'll let it as it is. And we will focus on the pages variable. One of the biggest strengths of Ruby is the functional way of how we can write code. So we will rewrite the last part as a one-liner. The first step is to use the predefined global variable $chevron to the left. It is an enumerator which gives us the inputs line by line. And with this, we can easily filter our data, filter the pages. Now, we are working with the filter block. In a block, we can give name to the parameters given to this block, but it's a bit too long. We will use a specific another pre-existent variable in Ruby, which are the numbered parameter for a block. So when a block receives several parameters, they are automatically stored in _1 for the first one, _2 for the second one, and so on. Just be careful if your parameter receives several elements, but you only use _1. _1 will have all the parameters stored as an array. In our case, we will just use the _1 to receive the page, so the line, the string. And to check if the super secret word is inside this page, we will use the following syntax. So it's _1, the page, and in between brackets, the secret word. This syntax will check if the secret word exists. If it exists, it will return the substring, so the secret word. If it doesn't exist, it will return nil, and this is how we will filter our pages. Now we can easily just apply the split method on our pages. By default, it will split by spaces. So now each page is an array with the word and at the end the page number. And we can easily now sort them by applying a sort by last. Since we are working with strings, we will follow the instruction with the lexicographical order for page numbers. We are not using the variable n with the number of pages, so we can remove it. We have to be careful because the line will be received on the input of our program, but the filter will automatically remove this line, so we don't have to care about it anymore.
So thanks to Sebastian, we now managed to get rid by almost half of the characters, and we end up with this input. So we got in our super secret form the word golf, and we got this in our pages. So the 2 pages who contain the golf keyword. So we can realize now that just by processing the input, we have already answered 2 of the 3 instructions. And we only have now to finally decode the message. For now, we will ignore the decoding part itself. We will comment it like here, decoded message plus equal next decoded letter. And we will focus on the looping part, on the each on the double each part. The first thing that we can do is remove the sort by last thing because Sebastian handled it for us. And we can remove the text and page number things because we will handle it later in the next decoded letter part. The page number will be filtered automatically. First, we will replace each block with map because we will gain 1 characters, and we will replace do and block with curly braces. And in addition into gaining a number by using map, it will allow us to return an array with the result of the code. So now we don't need the decoded message variable anymore. We can remove it, and we can simply join the result of the array by using the join function. And by that, this map actually return each letter. By doing the join, we got the word, and by doing the last join, we can concatenate each word in the final sentence. Obviously, we have to add a space because we have to add a space between each word. And when you know a little bit about Ruby, you know that instead of using join, you can use the syntax array times characters, which is an alias of the join function, and which is obviously shorter. The result is here. We can see now that the decoded message variable is useless. We can output directly the return of the map. So we can put directly here. We can use the tricks that Sebastian taught us. We can use the numbered parameters _1 instead of the page variable. And instead of put, we can use chevron to the left. No, we see chevron to the left to get the input, and we can use chevron to the right, which is an input-output flow to the standard output, and which accepts chevron to the left operator to add the element in the stream. So this is basically the same. And that's all for me.
Yes, thanks to Julien, we reduced this part by half too. So now we can focus on the next decoded letter part. So we have this is the code from our first version, and we will work to reduce this. The first thing we can do is to remove the decoded message variable. Julien worked to remove it, and since we are working with map now, we can just use the fact that the body of our if-else structure return their value, and just let the map work. The second thing we can remove, thanks to Julien, are the guards here. It was to handle the fact that a word, for example, can only be composed of vowels. And if there is no vowel, we wanted to have an empty string. We can remove them because Julien is using join, and join will apply the toString method on each of the elements before joining them, and nil toString in Ruby just give us the empty string. So we don't need these empty string guards anymore. The next part is to really shorten this if-else structure. And to do so, we have to identify that the condition is perfect for the spaceship operator. The spaceship operator will compare 2 variables, A and B, for example. If A is lower than B, it will return -1. If they are equal, it will return 0. And if A is bigger than B, it will return 1. The trick here is to use it as an index for an array, which will have the body of our previous if else structure. Indexes work like, for example, in Python. So -1 will be the last element of our array. The next step here is to remove the dot last and dot first. String can receive directly indexes, so you just have to replace them with indexes, -1 for the last and 0 for the first one. And now we will focus on the first line, where we were using partition to put on one side the vowels and on the second side the consonants. We can see in our code that we only use the first vowel of the word, so we will have a first regex just to match the vowels. And here in the second line, consonants, we will match everything which is not a vowel and not a digit. This is where we will filter the page numbers. Because if we have the page number, consonants will be empty. So according to the decipher method, we have to take the first consonant of the word, but since we have not, it will just be an empty string. Since the first vowel, we just only use it at one place, we can just move it to the array. Here we will use a syntax we saw earlier, where we use a string and between brackets substring to match the substring. We can use it with regexes too. So that's what we do here. So it will return the first vowel if one exists, or nil if there is no vowel in the word. A good thing we can use too in Ruby is that every assignation returns its value. So we can gain characters by using the assignation directly where we were using the consonants for the first time. We have to be careful to put parentheses to keep the order we want, but we can gain some characters here.
So thanks to Sebastian, we gained twice as much space, and when we merge our code together, we got finally 254 characters. There is still 3 more steps, very easy steps. The first one, rename the variables using only one letter variables. Second one, remove spaces. And third one, remove unnecessary line breaks. So we end up with this results, with 154 character results. This is not the shortest that we found, but it will be enough for today. If you want more tricks, you can visit our notebook. You can flash it, or I will put the link now in the chat. And you can also access it on our Twitch with a command line in the chat. As I said in the beginning, you can follow us on Twitch to see more tricks. There are also some very good programmers in Python, PHP, and JavaScript that come often to the stream, so you can also learn from them. And if you want to add tricks to the notebook, you can DM us on Twitter with the tricks, and we will add it. So thanks a lot for listening. And if you have any question, it's now or later on Twitter if you want.
Hey everyone, Mathis here. I just wanted to let you know that the video you just watched is part of a series of conferences we host at Coding Game. It's monthly, it's online, it's free. So if you want to register for the next session, feel free to do so. I'll leave a link in the description. See ya!